Welcome back students. In this video I am going to cover for you all one more question related to the course M1. It's all about to find the eigenvalues and eigenvectors of the matrix 3, 1, 4, 0, 2, 6, 0, 0, 5. If you look at the size or the order of the matrix, it is of 3 by 3. It has 3 rows and 3 columns. But whereas in the earlier video I have posted a 2 by 2 matrix and how to work out the eigenvalues and eigenvectors. Let's take into consideration the matrix is said to be matrix A, that is all about 3, 1, 4, 0, 2, 6 and 0, 0, 5. This is said to be a matrix A. In order to work out the characteristic equation, and from where we are supposed to work out the roots of the matrix, so that we are going to get the eigenvalues, and it is given as A minus lambda I, as hope you all are know that. So this equals to 0. Let's write matrix A. Once again, this is nothing but 3, 1, 4, 0, 2, 6 and 0, 0, 5 is said to be A matrix, and lambda is a scalar matrix and I is nothing but the identity matrix where the diagonal elements are said to be 1, and when I multiply this with the lambda, that becomes 1 into lambda is 0 lambda, and all the remaining the upper and lower triangular elements of the matrix is said to be 0. So this is how we are supposed to work out A minus lambda I to work out the characteristic equation. Now summing minus of these two matrices, so this row minus this row number, I mean 3 minus lambda and 1 minus 0 if you look at the second row, and the third is 4 minus 0, and this is all about 0, and this is 2 minus lambda, and 6 minus 0, that is 6, and later 0, 0 and 5 minus lambda, this equals to 0. This is the matrix which we have worked out, and from this we are supposed to work out the determinant of the matrix, isn't it, dear students? So this is further written as 3 minus lambda, 1, 4, 0, 2 minus lambda, 6, 0, 0 and 5 minus lambda equals to 0. So let's work out the determinant of this matrix in order to get the roots of this. So how to work out the determinant? This is a positive, negative and positive. So this row and this column need to be eliminated, so that you are going to get the determinant with respect to 3 minus lambda. The diagonal elements are said to be 2 minus lambda into 5 minus lambda, which I have done for all of you in my channel, how to work out the determinant and subtraction, addition as well as the multiplication of matrix also. So this is minus of 0 into 6 is said to be 0. Later we are supposed to work out the second row and the second column, isn't it? Second row and second column need to be worked out. For that I am going to get what here is minus of 1 into, so 0 times this is 0 and 0 times 6 is also said to be 0. Later the third row and the third column, the first row and the third column need to be eliminated, that is all about plus 4 into 0 times 0 is 0 and 0 times this is again equals to 0, the complete equation. So if you look here, dear students, this term and this term said to be 0, the finally I got the reduced equation, that is nothing but 2 minus lambda, 3 minus lambda and 5 minus lambda equals to 0. From this I can write down that lambda equals to 2 and lambda equals to 3 and later lambda equals to 5 are said to be the eigenvalues of the given matrix. So these all are nothing but the eigenvalues for the above matrix of the size 3 by 3. I hope you are catching my point how to work out the eigenvalues. Now let's look at the eigenvectors of this matrix. So for lambda equals to 2, I am going to work out the eigenvectors. So in order to work out the eigenvectors, I have an equation formula, that is A minus lambda I into x bar equals to 0. I know that A minus lambda I is already done here, and substituting the lambda value in place of this 3 minus lambda, this matrix, the complete matrix. So please kindly concentrate on this, lambda equal to 2, and I am going to substitute and work out this equation for you all now. So that gives 3 minus lambda is equals to 1, and this is 1 and 4 and 0, and 2 minus 2 is again 0, and this is 6. And here it is already 0, 0 and 5 minus lambda, that is 2, 5 minus 2 is 3 into, I can write the vector matrix, this is nothing but x, y and z. So this matrix equals to 0. Now let's work out the matrix multiplication. So 1 times x, row divided by column, multiplied by column, isn't it? 1 times x is x, plus 1 times y is y, plus 4 times z equals to 4z equals to 0. And if you look at the next matrix, that is about the third row and the third column, second place, this is 6 and times z equals to 0, and the later here also if you see 3 times z equals to 0. That means from these two equations I can say that the z value is equals to 0, z value equals to 0. Now what I am going to do here is let's considering y equals to C1, let y equals to C1 and substituting in this matrix z equals to 0 here, isn't that? Z equals to already 0 and y equals to C1 if I am substituting. So x becomes what, dear students? So x is also going to become C1 here. So x value equals to C1. I hope you are getting my point. I mean negative C1 you will be getting here. So this is that. So when you substitute this in form of matrix here, this is all about x, y, z. So this is nothing but -1. If I take C1 common out, so -1, 1 and 0 if I take this common. So these are nothing but the eigenvectors for lambda equals to 2, dear students. For a value lambda equals to 2, you are supposed to work out this. Now for lambda equals to, the next lambda value is all about 3. For lambda equal to 3, I need to work out the eigenvectors. So that is nothing but I am going to substitute this a minus lambda in the place of lambda. You are supposed to substitute 0. Isn't it, dear students? You are supposed to substitute 0. So what? Sorry, lambda in place of lambda you are supposed to substitute 3. So that becomes 3 minus 3 is 0 and 1, 4 and this is already 0. 2 minus 3 is nothing but -1 and 6 and this 2 are already 0 and 5 minus 3 equals to 2 into x, y and z. This matrix equals to 0. So from this I can write the equation 0 times x is 0 and 1 times y is y plus 4z, y 4z equals to 0 and minus 0 of this is 0 minus y plus 6z equals to 0, and later if you see here this is all about 2z equals to 0. So if you look here, dear students, again z equals to 0, I mean z equals to 0. If I substitute this here 0 in place of z, so the y is become also, y also becomes 0, and where I consider the x is nothing but C2, let x is C2. So from this I can work out the eigenvectors for this matrix, I mean for lambda equals to 3, this is being found out to be, if I taken common C2 here out, so this is 1, 0, 0. So 1, 0, 0 are said to be the eigenvectors for a value lambda equals to 3, dear students. Hope you are catching my point. This is how you are supposed to work out. Later the next the eigenvalue is all about lambda 5, lambda equals to 5. For lambda equals to 5 we are supposed to work out the eigenvectors. So again I go with the characteristic equation, so that is all about this, and in the place of this you are supposed to substitute what, dear students? In the place of this matrix A minus lambda I, phi need to be worked out. So that will be nothing but -2, 1, 4, -2, 1, 4, 0, -3, 6, 0, 0, 0, and this is nothing but x, y and z matrix, that is equals to 0. So again the equation is that -2 into x is nothing but -2x and plus 1 into y is y and 4 into z is nothing but 4z equals to 0. Later 0 times x is 0, minus 3y plus 6y equals to 0, and I consider now this z equals to C3, let z equals to C3, sorry this is z equals to C3. I am going to substitute this in this, so that will be minus 3y equals to minus 6z. So positive, both we get positive. So 3 1s, 3 2s. So y equals to 2z. So this is nothing but 2c3, isn't it? As I took the value of z equals to c3. So y becomes what, dear students? Y equals to 2c3 and z equals to c3. Now when we substitute this here in this equation 1, let it be x and y, z and y values. So that will be minus 2x plus y is how much? 2c3 plus 4c3 equals to 0. Getting, dear students? I hope you are getting what I am speaking here. So plus 4z. So the finally this equation is reduced to minus 2x plus 6c3 equals to 0. So what happens to this? Minus 2x equals to minus 6c3. So negative and negative gets cancelled 2 times and 3. So x equals to 2c3. X equals to 2c3. Now when you look at this relation, the characteristic equation as well as the working out the eigenvectors for lambda equals to 5. So this is given as x, y and z. I am going to take c3 common out here. So when I take common, this is 2 here, 2c3, and this is also 2, and even z is nothing but c3. So that, sorry, this is 3, right? This is 3 and this is 2c3 and little later 1. So these are the eigenvectors for the lambda equals to 5. Hope you are catching my point and you understood the way how you are supposed to work out when the matrix is of size 3 by 3, dear students. This is how you are supposed to work out the problem. For sure you are going to get such problem of size 3 by 3 or 2 by 2 in your exam. The question number may be 3 or 4, and please do work out and practice many such problems to score good marks and out of out mark if it is asked to work out the eigenvalues and eigenvectors. Hope you are liking my videos. For more videos, please do subscribe to my channel as well as share this video to your friends which may help them too. Good luck. Thank you.